session is kind of about you. So if you got questions or you want to talk about things, we'll try to get the appropriate topic up on the screen for you. But it's called Top of the Tower. Oops, I do have an advancement here. You know, and everything starts at the top, okay? Including our government and everybody else within their systems here. But this is the typical top of the tower. You don't get this side view on towers very often, you know, unless you're from a crane or building a tank right next to it, a sister tank, or a little airplane. And that's my next inspection tool. I'm going to get one of these little helicopters with a camera on it and fly around and look at tanks so I don't have to climb anymore. I'm getting old. So anyway, this is what we're looking at, a bunch of water towers and anything you've got on it. Here is the topics. I know they're a little bit far for the back row to see, but we have safety, tank elevation, evaluations, design, new tank construction, antennas, reconditionings, coatings, ice prevention, mold, mildew, biofilm, interesting pictures, some maintenance plans, contractors, where I go from now. What do you guys want to talk about? What is hot in your world? What is important to you? That's where we're going.
Mold and mildew.
Mold and mildew. For 600. Mold and mildew. And the first guy who said that gets choice of hat. Which hat?
Do they have a light in them?
Yes, they do.
I'll take
Which color? The camo.
I got the
camel this time.
This time, he knows my gig. He's in cahoots. All right. What number are we at? Oh, we got to escape here a sec. What was it?
Mold and mildew.
60? 600? Oops. All righty here. So now you got to bear with me a little bit. $165? Boy. Should know my own topics, right? A lot of them. Plus I added some. All right. All right, mold and mildew. What do you guys want to talk about? How to prevent it? How to keep it on there? What do you want to deal with here? Oops. I'm supposed to go into a little slideshow here. It is getting to be a bigger problem with the mold and mildew issues out there. And I don't know if it's the coatings that were put on 5 and 8, 10 years ago or what is going on with it. But typically you can take care of it and power wash it off and remove it. There's some new processes out there for chemically cleaning and treating it, and hopefully we're going to get more than 8 years out of it before it gets moldy and mildew. But the reason it forms on here a lot is how your tank sweats. Okay, the environment it lives in, the pollution that gathers on it, and mold and mildew can also be considered a biofilm. So you look at it as a biofilm. How do I kill or remove that and clean that? And again, I don't want to take off the coating, so I hope I got a good coating system there with some cohesion to the substrates so that we're not going to blow off the coatings. These were some rust failures that we're taking care of and already in the primer stage of it. But a lot of times you'll power wash it so you can overcoat it, power wash it to clean it so you can get another 8 years out of it before it gets dirty again. And by the way, I forgot to mention that the camera has been facing this way all day. I think we should turn it around and face the audience, okay? I've sat in about 4 sessions in here all day and I'm going, this is a beautiful crowd. Why look at the speaker here? Let's get it out there a little bit. All right, again, biofilm is treatable. The problem is, what's it cost to get rid of it? How often do I need to do it? What am I going to do to keep it from coming back anytime soon? Is that all I had on biofilm slides? Like 2? Okay. The reason that we have some of this biofilm that grows in there too is the coating system and how it was applied. The material that was used might be a problem. How it was applied, was it rolled on? Because rolling will give you more of a stipple effect, a textured type of look versus a sprayed on. So usually when we're doing tanks, we spray the primer, we spray the intermediate, and then we roll the finish coats on to make sure that we got as smooth as coating as possible so there's less area for the coatings to grab a hold of. But primarily the main thing is it is treatable. In a life cycle of a tank, you're looking at painting it. Maybe 8 years later, you got some biofilm. 10 years later, you got it cleaned off. Another 8 years, you got it cleaned off again. So you're at 16 to 18 year mark when you're removing all this biofilm or mold. And then at that next one, you're probably looking at a full reconditioning again at the 22 to 24 year mark. So in a life cycle of a 20-year coating system, you may be power washing or removing the biofilm at least twice, depending on how well it was cleaned and what was used. I was over in Germany a couple years looking at some chemical treatments for how to remove and kill and take care of this biofilm. And we had a couple products out there that we've been experimenting with to help all these contractors remove this stuff and get 10 years or more out of it before you have to repaint it or re-clean it. And we did 2 test samples on a 20-foot panel. And on the test samples, we sprayed the chemical on and power washed it with 3,000 PSI rotating head, about 10 to 14 inches away from the surface. And on that test panel with the chemically treated, it took 8 minutes to remove a 20 by 8-foot sheet, okay? Without the treatment, it took over 20 minutes to blast 1 sheet of it. So there was some time savings for the contractor just to remove that and not waste a lot of time in those panels. And we're talking some big tanks that we were cleaning at the time, or experimenting with at the time. So the rest of the tank we cleaned with this chemical treatment. In the past, we were able to use a chlorine bleach solution type, and again, the environmental protection says, hey, you're killing the birds, which are eating the worms that you killed in the grass and everything else around there. So we've had to look at different types of cleaning and how that goes. Some people say, well, you're using too much pressure, you're going to blow the coating off. Well, if you're going to blow the coating off, the coating was no good to begin with, okay? The coating has a PSI that it should be together. I mean, like I said, you got the substrate of your steel, you got your primer, your intermediate, and your top coat, okay? And all of those should be bound together, cross-linked, and you should not be blowing off the coating unless it's a really old coating system, you know, pushing 18 to 20 years, and then you get close to that reconditioning life cycle. But, I don't know, there we go. Here's some other types of power washing equipment that's out there. You can do it with a extended wand off of a basket. This was a rotating machine that went around the tank. And again, it's a matter of how close and how much pressure you're using. It's not a real hard job or a real difficult job. Depending on the style of tank and the size of tank is really what it's going to cost you. Normally I see it anywhere from $5,000 to $12,000. You get into larger tanks, you're going to get into a little bit more cost. And the degree of difficulty, a Lega tank is going to be harder than a single pedestal spheroid. Okay. And then we're going to go to the next topic. Does anybody remember what it was?
I got one question.
Oh yeah, question.
Besides aesthetics, does the molds and mildews accelerate corrosion?
It'll accelerate the corrosion, but it's not going to take away from the coatings. Okay, the coatings are the coatings, but it's not, the mold and mildew, if you got bare spots, yeah, you're going to have biofilm and some other areas that are going to corrode, but for the most part, no. Yes?
One thing about what I asked is because I got a standpipe and I got a guy in town with a pressure washer and a steamer in his truck.
Yep.
Got the city bucket trucks, but on the top, my concern is chemicals I put on the tank is they're going to get sucked in inside the tank with vents. That was, my main. Is it like safe stuff that if it does get inside, I don't have to?
Well, it's NSF approved material. I guess you have a vent up there and you have a manway.
Yeah.
I mean, if you're going to spray it, usually you start at the top and work your way away and down. I would seriously doubt that you're going to contaminate any of the tanks. That's a good question though, because I've never been asked that. It's a really good question. But I seriously doubt that would happen. Yes, sir.
When you wash that off, a lot of times there's significant staining. Is that a sign of poor coating?
When you wash it off, there's a significant staining. Is that a sign?
After it's cleaned, you can still kind of see the shadow of
Yes.
where the mold was. On one of your pictures, you can actually.
Kind of like a bed or glue right in.
Right, and again, more than likely, if you ever watch your tanks, as they get dirtier, it's always going to be on the north side where you don't get enough sunlight or air taking it off of there. And I would agree with you. You are going to have more staining and harder to get off, unless maybe this chemical treatment's going to take care of it for us.
That's not necessarily a sign that you have coating.
No.
The chemical you're talking about is not food grade?
It's not a food grade.
He was asking about it.
No.
But it's not.
Not a food grade.
Sean, can you repeat the questions, please?
The question was, the chemical we use, is it a food grade? Is it NSF approved? No, it's not a food grade approved. It is chlorine or similar to chlorine bleach. It's kind of high vinegar type of thing to it. So, all right, Remind me if I don't get everybody on the questions, or repeat it, so remind me. Any other questions on tank cleaning exteriors? Again, they're gonna change every year, but I'm seeing right now that 5, 6, 7 years, it seems like these whiter or lighter colored ones are getting dirtier faster for some reason. The newer coating systems that we're seeing out there, we have high expectations, this hydroflon and some of these urethanes that are out there, that we're gonna have less and less, and maybe we'll get 10 to 12 years out of them before they actually get dirty. One thing you could look at is, I've seen this more and more too, is that people are two-toning their tanks. Lower portion of the bowl is being a darker color, and the upper portion striped lettering, whatever, and the upper portion being a lighter color. The other one thing that I did want to mention about this is that it seems to be when we get on some of these tanks and there's a lot of debris on the tanks, I mean as in birds, killing birds or rabbits or whatever else, all of that stuff ends up sliding down the tank during rain and snow and whatever else. So, and the snow adds a lot of dirt to it as well. You know how dirty it can be with the pollution and stuff. But it's kind of something I've always paid attention to, is you see all these dead carcasses of birds from bigger predator birds, and you go look at the tank, and yeah, there's probably some of that added to it. You know. Questions? I would say we're done, but we're not. Mike won't let us go yet.
Did everybody sign? Gotta have some questions, gotta be some questions out there.
Okay. What's that? Recoding? Where's my mouse? Should have Mike do this. Remember
You
what
had a
recoding?
million slides.
I know.
Running all here.
I gotta go back to 3. Oops, 4. Recoding which one? Reconditioning, 82? Alrighty. And you pick the second topic, you get a hat, and I'm breaking it down. You can get a Post-it cube. Hat, Post-it cube. Hat it is. That means the rest of you guys all get Post-it cubes if you ask. So I told you to take that. So you could have it? All right, reconditioning. You're working me pretty hard here, okay? That's all right. Technical specifications, by the owners. Before you get into the reconditioning of water towers, pretty important to do your, engineering study of the tank. Preliminary engineering report or inspection or evaluation of the tank ahead of time to know what you're getting into with the costs of doing this tank. 2 things I get asked the most is, how much is it going to cost and how long am I going to be out of service? You guys deal with it being out of service. How am I going to distribute water, keep everything up in production? Administrators want to know, how much is it going to cost? What do we need to budget? Where do we need to get loan money, et cetera, and that's a very important question. But unless you have that preliminary engineering report done and have that inspection done, there's a lot of wiggle room for problems with it, okay? And what I mean by that is there can be change orders. So you want to make sure you know exactly what you're putting into that specification ahead of time. And it's very important that you're bringing your tank up to code as far as AWA standards, 10 state standards, Department of Health, OSHA, all of these things are important to bring your tank up standards if you're doing a major reconditioning, okay? If it's a minor one or just an overcoat, some of those things are needed and required and necessary. But within that specification, you want to make sure you get the coating systems that you want. Again, each tank is a little bit different. You want to make sure you're putting the right coating system within that tank. I know of a tank that got painted and the entire tank blistered and failed within 2 years of it. Totally wrong system for the tank. And they ended up repainting it right away. Luckily, they caught it in a warranty and there was some shared costs. But again, you want to make sure you're putting the right coating system together for that particular type of tank, if it's a sweating tank or whatever it might be. Also, the contractor's qualifications. Yeah, everybody's got a pickup truck and a ladder and can paint, but can you paint a water tower? Okay, it's a little bit of a different beast, a little different animal. So the contractor better have some qualifications. He better have some references then that he has done that tank, 5 times over, or greater, and he met the schedule, and he didn't ask for a lot of change orders, he didn't have a lot of extra costs involved with it. Main thing is, you got your tank out of service for 6 weeks, you don't want it out of for 12 weeks or 10 weeks, you want to take care of it in 5 or 6 weeks. So you want to hold these contractors accountable for their schedules. So their qualifications need to be looked at very, very deeply. Submittals, there's submittals that need to be sent in from these contractors on vents, manways, handrails, safety climbing devices. All that stuff needs to be looked at and reviewed by your consultant that is helping you with this project. And it's very important that you get all that done before you even have a pre-construction meeting. Shop drawings, there's generic drawings and then there's the real drawings, as-built drawings. At the end of the job, you want to make sure you have all the as-builts in your hand, in your file, copied at City Hall or whatever else it might be. So you want to make sure you have all that. Welders qualifications. Yeah, a lot of guys can weld, but can they weld overhead 120 feet in the air with wind blowing on them? Okay, a little bit of a different story when you start getting into this structure and how well they can do that. When we do new tanks, we're looking at all their welders and welder qualifications, their certifications, and what procedures they can do and what they can handle with that. So with that being said, the main thing is, before you get into the paint reconditioning, a good thing to know is what exactly you got to do. That phase 1 type of inspection evaluation will save you money in phase 2 and phase 3 when you're doing the actual work of it. So let's see what we got for slides. Most of the tanks we're seeing today are having a full containment on the reconditioning system. It used to be just because of lead, okay? But now we're looking at full bonnets, containment going up, negative air, keeping it all on the owner's property. We're not letting the particulate fugitive matter drift into the parks or the parking lots or the neighbors or the gardens or any of that kind of stuff. So we are using full containment systems on these, and it's an added 40, 50, 60,000 depending on the size of your tank. The good news of a containment system is they can blast longer in the day if they've got the right weather, and they can spray paint the first 2 coats on it and then roll that finish coat on it. Okay, so they can spray within this containment system and give us a better looking coating system in the long run. The negative side of it is if it's windy, 10, 12 mile an hour winds, those containments are usually coming down. They're not going to push it to 15 mile an hour winds too often. Okay, it'll happen occasionally, but not too often. So when it's windy, they got to work on the inside or they're done for the day. Okay, or they're re-rigging or doing some other thing. So there's advantages and disadvantages of the containment system. It does add some costs, but it's limiting your liability as far as being sued by the public or some other problems out there. Again, we talked a little bit about the OSHA compliant. Do we have handrails and things up to speed? Now's the time to fix it. Codes change throughout time, and we get some of these tanks that are over 20, 30 years old, and the code has changed again. So we want to make sure we're keeping up with at least the OSHA stuff. Yes, sir?
About what time did they get away from rivets?
Rivets ended shortly after World War II. We did see a few into the 50s, early 50s, but the question was, when did rivet tanks disappear as far as going to full welding on it? And it was the late 40s, early 50s was when we started seeing more and more. We're getting fewer and fewer riveted tanks out there, and the ones that we do have out there are landmarks or historic value of some sort. But there's still a number of them out there, and again, bringing them up to speed and safety-wise, it's hard to say if it's worth sticking $100,000 into fixing this tank or building a new tank for $250,000 and going a little bit bigger. So that's part of that phase 1 assessment, is knowing exactly what you had. Again, OSHA compliance means bringing your handrail up to snuff, putting a mid rail and some vertical rails in there. Overflow had to be modified. A number of things needed to be done to make it OSHA compliant. The handrail, boxing in the existing manway, putting a cage on it, safety climb device, a number of things that add up to $10,000, $20,000, $30,000 of structural repairs that weren't on that tank originally or similar to it. And you can see here, there's the containment arms going up from this perspective as well. There's the full containment. If you look at the equipment that these guys now bring to these jobs, it's quite a bit. I mean, it's expensive, labor's expensive, fuel is expensive, their insurance is very expensive. Our insurance is expensive now because we've got all these cell people running around on these towers. There used to be just certain amount, now you've doubled or tripled that with all these cell sites being used on, or cell people running around on the water towers. So the more people running around it, it increases everybody's rates in this type of a business. But as you can see right here, they've got some major power lines very close to this. So structure-wise and containment-wise, you've got to look at what that site can actually do and what we need to do for protecting everybody else. The other thing is trees need to be trimmed, maybe cables need to be, or the wires need to be covered, a number of different things, or the transformer shut down. So we have to take that into that phase one evaluation and say, what do we need to do to fix this? One of our major problems with containment is cellular sites. You got all these little fenced in places around there, and you want to have the diameter of that tank plus 8 to 10 feet before you have any site with a fence or a cellular location. So it's the diameter of the tank that's your concern, okay? You don't want it in there, and if you got it outside of there, underground, then popping up, that's the best way to do it for all these contractors. Otherwise, it's more money. It's gonna be a lot more money to work that. All right, let's see what else we got here. This is looking inside the containment, up the inside. It's kind of a rare look, for guys like you, we see it all the time. It's kind of interesting. You can tell they're getting towards the end of their job because they wear out these tarps. That sandblasting, abrasive blasting is hard on equipment and tarps. And they're getting towards the end of this one, and they'll actually just throw that piece away and add another new one in on their probably their next job. But it's getting towards the tail end of the life expectancy of that tarp. Here's another little single pedestal, got the bonnet on it, got the cables hanging off of it. What we see on these is you have to know the structure, like that riveted one we saw. Can that roof handle that load of all that weight being pulled on top of it, plus your containment, the wind loads on it? So you have to kind of engineer it and look at those plans when we're talking about those drawings. What is their containment plan and how is that going to work with this particular tower?
Do you just spot paint around where those supports are attached to the roof?
Question is, do we spot repair around those supports? Well, where these outriggers are, yes, that's what we do. When the containment is all done and we still got these little patches up there, we either spot blast them or we power tool clean them and get those. So those are the last that get primed, intermediate, and then everything gets finish coated. Good question. You're looking for a cube, aren't you? You're going to get one. All right. Again, another look inside the containment system, looking up. You got different areas that have been blasted. Here's blasted, primed areas, and then you got the old coating system in there as well. Still fairly well into the job. Kind of moldy, mildewy, a little bit of rust going on. Just giving you a perspective of inside of it before it gets dusty again. And within all of these upgrades that we're doing, you see these brackets over here and these brackets here. This is all the antenna upgrades. This is the best time to get it done. Okay, I know you talked about antennas earlier, but this is the best time to get all those welded brackets put into place for future or existing systems so that it's minimum amount of impact on everybody else that's going on the tower. Again, a single pedestal with a blasted steel, containment bonnet on it, negative air. One that's been zinc primed, and now they're working on the intermediate coating. Again, I said they can spray it a lot faster than they can roll it, and you get a much better, more uniform job with the right dry film thicknesses. Got a little shot at it. With that, we're talking about some of the repairs, interior and exterior repairs. Manways, vents, all of those things we should be looking at to find out if they need to be modified and upgraded. A lot of these old vents don't meet Department of Health. We have driving rains that can get in there. We got undersized screens or no screens. We got problems with that. We want to make sure we got plenty of clearance. I've seen some that are tight like this in Minnesota, and you get a 10-inch snowfall, you're not helping that thing breathe very well. So there's a lot of types of modifications, and that's why when we sit down with you after we've done our evaluation, we can explain why these are in the report and what you need to modify them. Can justify it a little bit with the decision makers. And then there's inspection during the reconditioning. You have the proper credentialed type of inspectors looking at it, NACE certified, AWS welding inspectors, things like that. And what they do is they're looking for the daily logs, the weather logs, surface preparation, any welding that was being done on it. and the schedule and the weekly summary. I mean, those are important things in case there is a 1 in 1 zillion chance that we're gonna have problems. They're there to help you assure that the contractor is doing it according to the spec. You're paying big money for the reconditioning. You wanna make sure it's gonna get that 20+ year life cycle out of that coating job. And a couple finished pictures here around the state. Here's a little good one. When we do these reconditionings, you can see the old riggers for the tabs. We typically pull off the antennas, okay? We do not work with them in place. They get moved to a cow, cellular on wheels, off-site, just a little bit, or they put a monopole in there. And then once all the painting is done, they go back and reinstall all of their antennas in their system. And then they have to do some touch-up if they do any damage of that. Then you're looking at a 1 or 2 year warranty period. Okay, you go back into it within the 2 years to make sure everything is still looking good, because that contractor is liable for that. That's what the insurance bond is about. So you make sure that you've got the coating system as perfect as well as we all know it can be. Oops. A couple more tanks. It all starts here, damn it. Whatever that means, but we got the little slogan there. A couple other ones here. All right.
At your 2-year inspection,
Yep.
how often do you run into issues that have to be fixed?
At the 2-year inspection, the question is how often we run into issues. We're not running into issues anymore. We've got a system that is in the last 5 years. I don't think we've had any that were an issue that needed to be a contractor come back and fix it. And by doing at the 2-year inspection, we're not draining the tank anymore. We're going in with robotics and swimming it around so that you don't have to, it doesn't change your operations at all. Because primarily at that time, we've done all the structural repairs, we've done the coating replacement. Now all we're looking for is any coating blisters or any major problems. Could be some ice damage or something else, but we're looking at it, giving it that good 2-year, 22-month look. And if the tank has got a blessing, down it goes. You know, you're good to go. If it's got some blisters or whatever not, then we're gonna get the contractor back and he's gonna pay for it to fix it. And now you are gonna have to drain it and take care of it, or take it out of service for a little while. But again, you'd rather know that up front than 3 years later or 5 years later at the 5-year anniversary inspection. So, again, I talked a little bit about the structural, the coatings, OSHA, Department of Health, EPA. All of these things are important when you're going into that full reconditioning phase of it. Coatings, material selection, surface preparation, application, inspection, of course, and then, of course, the warranty. On the interior abrasive blasting, again, it's different than the exterior abrasive blasting. You're looking for an SP10 versus an SP6, depending on what you have on the outside. When we have lead on these outsides, we're still pushing for an SP10. Okay, we want all the coating, all the lead off, no matter where it's at. So the abrasive blasting is taking place. You prime it in. This is a stripe coat, okay, of the irregularities, the weld seams and stuff like that. And then once it's been finished coated, then we can go in there and do some dry film thicknesses. You're doing it on the primer, the intermediate, and the top coats with any of the coating systems that are there. And then in some cases, depending on the spec and the coating system, the tank, you're doing what's called holiday testing. It's a wet sponge, okay, he's got a little bucket of water there, and he's sponging all these areas to make sure that we're not having these discontinuities. And that is why we're passing the warranty, okay? You put a 3-coat system in there, you're sponging all of these weld seams in the tank or any irregularities, pits, corrosion, undercuts, whatever. And if they sing, if they beep, 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 you're circling it, contractor comes back, he's cleaning it up, putting 2 more coats on there, we sponge it again later to make sure it passes. And that's why we're getting through the 2-year warranty. And that's why we're not having any problems. So now, when you look at the coating system, at the 2-year warranty, there's no failures that are visible. Now you're filling it up with water. 5 years later, maybe